Alright, hi, my name is Ethan Lang, and I set out to investigate the dynamics of this ball I have in my room. This ball. And this example is relevant to me because I just like basketball, so kind of just tracking down the motion of the ball itself kind of seemed interesting to me.
To analyze my video, I put my video into Allegro Pro, and then I recorded the movement of the ball throughout the video. So I then took the graph given to me, and I found the curve fit of both the vertical position time graph and the horizontal position time graph. The curve fit for the vertical position time graph was quadratic, and the curve fit for the horizontal position time graph was linear. Okay, so this is my lab report where I basically just wrote down some data, and I also wrote down the formulas I used for my experiment. So the first thing I did was I weighed the ball. I weighed the ball on the scale and found out the mass of the ball was 307 grams. So I then took that mass and I multiplied it by 10 to find the gravitational force. And that gave me a gravitational force of 3,700 newtons. So now I can find both the normal force and the friction force. So to find the normal force, I use the formula of the force times the cosine of an angle. And since I did my experiment on a flat surface, you can see that the angle is 0. So I then took the gravitational force of 3,700 and I cosigned it by 0, which gave me a normal force of 3,700 newtons. And for the friction force, I use a formula of the force times the sine of the angle, and since again there is no angle, I had to sine the 3,700 by 0, which gave me a total of 0 newtons of friction force. And then for the kinetic force formula, I just divide the friction force by the normal force, which is 0 divided by 3,700, which gave me a total of 0 newtons. So yeah, I then took all that and I made a force diagram. So yeah, there's only two forces basically. There's the normal force, which is 3,700. There's also the gravitational force, which is 3,700. And then there's also the friction force. Well, not really, I just wanted to write it in, but it's non-existent. There's 0 newtons of friction force. And for my system schema, it's pretty basic. There's two forces running between the earth and the ball, and there's a force between me and the ball, which is me pushing the ball, and a force between me and the earth, which is the earth weighing me down. And then for my motion map, it's just showing basic or a gradual acceleration of the ball. It starts off small, and then it gradually gets larger, showing the ball speeding up. And this is my vector addition diagram, which is very similar to my force diagram, showing the normal force of 3,700 newtons and the gravitational force of 3,700 newtons again.